What is an earthquake? An earthquake is the sudden release of energy from inside Earth, which can result in significant shaking of Earth's surface. The energy is released when movement occurs along large cracks called faults in the Earth's outer layer. More than 90% of all earthquakes are caused in this way. There are many different types of faults, and the earthquakes that occur on them may result in side to side and up and down shifts of the Earth's crust. Melted rock called magma rising towards Earth's surface can also cause earthquakes. This usually happens before a volcano erupts. Only about 5% of earthquakes are related to volcanic activity. Volcanic earthquakes are generally relatively small and often not even felt by humans. On this photo here, you can see three different types of faults shown, one being divergent, one being transform, and then one being convergent. And so when an earthquake occurs, surface features or rock layers near the fault may be disturbed. So what do you notice about the rock layers and the surface features near each fault in these three different photos? Describing earthquakes. An earthquake can be described in two ways, by its magnitude and by its intensity. Each description provides scientists and others with important data about the earthquakes and its effects. The scientists who study earthquakes are called seismologists. They can use data to assess the risks of an earthquake-prone region and prepare for future earthquakes. So learning about magnitude here, an earthquake with a magnitude of 6.0 occurred today. You may have heard a similar announcement during a news broadcast. On another day, you may have heard an earthquake with a 7.0 magnitude. Well, how do these numbers describe the two earthquakes? Magnitude is a number that describes the total amount of energy released at the source of an earthquake. One well-known way to measure magnitude is using the Richter scale, named after the seismologist who developed it. You can see the photo here of Charles Richter. In 1935, Charles Richter developed a mathematical way to convert measurements that he collected about earthquakes into a numerical scale. Richter scale measurements enable scientists to compare the strength of different earthquakes around the world. The magnitude of an earth is determined by measuring the amplitude or height of the largest recording on a seismogram. A seismogram is a kind of graph of waves produced by an earthquake. As of 2016, the most powerful earthquake recorded measured 9.5 on the Richter scale. That earthquake occurred in Chile in 1960. The most powerful recorded earthquake in the United States occurred in Alaska in 1964, and it registered at a 9.2 on the Richter scale. And you can also see a photo here with the table describing the Richter scale and the intensity levels of it as it goes up to a higher number. Learning about intensity now, scientists use intensity to describe the kind of damage caused by an earthquake as well as people's reactions to it. In other words, intensity is a measure of earthquakes' effect on people, structures, and the natural environment. Many factors affect intensity. These include how far the location is from the fault where the earthquake occurred, the depth at which the earthquake occurred, the population density of the area affected by the earthquake, the local geology of the area, the type of building construction in the area, and the duration of the shaking. Magnitude also affects intensity because an earthquake of a higher magnitude releases more energy than an earthquake of a lower magnitude. But an earthquake in a densely populated area that results in many deaths and considerable high damages or high intensity may have the same magnitude as an earthquake in a remote area that does no more than just frighten wildlife or has lower intensity. The scale scientists use to measure earthquake intensity is the modified Marsali intensity scale, and it's named after the Italian geologist Giuseppe Marsali. The scale ranks earthquakes on a scale from 1, or Roman numeral 1, which means no damage, to Roman numeral 13, meaning total destruction. Can you guess why the Marsali scale uses Roman numerals? And you can take a look here and see the intensity scale using Roman numerals 1 all the way through 13. They tell you about the damage and intensity of the earthquake there.